Welcome friends. In this video, I will discuss a problem which was asked in West Bengal Joint Entrance Examination 2023, and I use the booklet code C and question number 1. What is the problem? Limit x tends to infinity x minus nth root of x minus a1 times x minus a2 x minus an, where a1 a2 n are positive rational numbers. Then the limit option A does not exist. Option B is a1 plus a2 plus plus n by n. Option C is nth root of a1 times a2 times an, and option D is n upon a1 plus a2 plus plus n. To calculate the limit, we take, let y equal to 1 upon x, then y tends to 0 as x tends to infinity. So, limit x tends to infinity x minus nth root of x minus a1 times x minus a2 times x minus n is equal to limit y tends to 0, 1 upon y minus nth root of 1 upon y minus a1 times 1 upon y minus a2 times 1 upon y minus an. We have y tends to 0, 1 upon y minus nth root of 1 minus a1 y upon y into 1 minus a2 to y upon y 1 minus n into y upon y. On simplification, we get limit y tends to 0, 1 upon y minus nth root of 1 minus a1 into y times 1 minus a2 times y 1 minus n times y divided by y to the power n. On simplification, we get limit y tends to 0, 1 upon y minus nth root of 1 minus a1y times 1 minus a2y times 1 minus a1y divided by y. So we have limit y tends to 0, 1 minus nth root of 1 minus a1y into 1 minus a2y 1 minus ny divided by y. Now, since y tends to 0, therefore a1 y tends to 0, and hence 1 minus a1 y tends to 1. Similarly, 1 minus a2y tends to 1, and so on. 1 minus any tends to 1. Therefore, the product 1 minus a1y into 1 minus a2y 1 minus any goes to 1 also. And this implies that nth root of 1 minus a1y into 1 minus a2y 1 minus any goes to 1. Consequently, 1 minus nth root of 1 minus a1y times 1 minus a2y 1 minus any goes to 0. So, this expression is 0 by 0 form. By using L'Hopital's rule, we have y tends to 0, d dy of 1 minus nth root of 1 minus a1y, 1 minus a2y dot 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 1 minus any divided by d dy of y. And hence we have this expression. Since d dy of 1 is constant term is equal to 0 and d dy of y is equal to 1, so we have limit y tends to 0, 0 minus d dy of nth root of the expression 1 minus a1y, 1 minus a2y dot 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 1 minus any divided by 1. Consequently, we get this. Therefore, limit y tends to 0 minus limit y tends to 0 d dy of nth root of the expression 1 minus a1y, 1 minus a2y dot 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 1 minus any. So, the required limit is nothing but minus limit y tends to 0 dp dy, where p is equal to nth root of 1 minus any, 1 minus a2y dot 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 1 minus any. Now we have to calculate dp dy, limit y tends to 0 dp dy. P is equal to nth root of 1 minus a1y times 1 minus a2y dot 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 1 minus any. Taking logarithm of both sides, we get log p is equal to nth root of sigma k equal to 1 to n log 1 minus aky. Taking derivative both sides, we get the dy of log p is equal to nth root of k sigma k equal to 1 to n d dy of log 1 minus aky, which gives 1 upon p dp dy is equal to 1 upon n sigma k equal to 1 to n minus ak divided by 1 minus aky. And this implies that dp dy is equal to minus p by n sigma k equal to 1 to n ak divided by 1 minus aky. We get limit y tends to 0 dp dy equal to minus 1 upon n sigma k equal to 1 to n ak 1 minus ak into 0 minus 1 upon n k equal to 1 to n ak. This implies that sigma minus limit y tends to 0 dp dy is equal to a1 plus a2 plus dot 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 n upon n. The required limit is nothing but a1 plus a2 plus dot 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 plus n on n. So, option B is correct. Thank you for watching this video. Please subscribe our channel for seeing this type of videos in future.